Hi all, welcome to my channel Mathematics Idea. This video is also available in Hindi. यह वीडियो हिंदी में भी उपलब्ध है. If you are first time appearing to this channel, then I will suggest you to go through my introduction video first to understand the presentation structure of the course content. Today we are at detailed explanation class 5 for the matrices. This detailed explanation class 5 is based on properties of determinants. We had already covered determinants in our previous detailed explanation classes. I will suggest you to go through that series. First complete the introduction, rest of the detailed explanation classes where we are having our determinants as well. Okay. Now, in this detailed explanation class, we will cover the properties of determinants. Okay. So what will be the roadmap of today's class? Today's class roadmap is we will complete the properties of determinants in this detailed explanation class 5. Okay. Now the basic structure of the class is it will be like del equal to something or del equal to something. That means del equal to suppose x. If this x can be transformed to mx as well. How we will transform? Those are all will be covered in the properties. Each property will tell how we can write this x as something called as mx. Okay. If some elements in the del are changing, if some rows are changing to the columns or columns are changing to the rows in a determinant, del is the keyword for a determinant. It is a symbol. Okay. Del is the symbol, delta is the symbol for the determinants. So my determinant, I will take one symbolic representation of the determinants as A1, B1, C1 as first row, A2, B2, C2 as the second row, A3, B3, C3 as the third row. Okay. So we will see how x can be mx if some changes in the del are there, some changes in these elements are there. Okay. How x will become as mx. Okay, this is what we will see in our properties. How we can hold these things in our properties. Chalo, we will start our property number 1 today. Yep. Let's go through our property number 1. What does property number 1 says? If suppose my delta is A1, B1, C1, A2, B2, C2, A3, B3, C3, or my delta will be A1, A2, A3, B1, B2, B3, C1, C2, C3. So what are the changes you had seen? We had seen the changes that it is a 3 by 3, that of the 3 by 3 matrix in which A, B, C were rows earlier. Now it had become a column. A, B, C had become a column. So we had gone through one of the operation of the matrices which is transpose. Okay. So once we take the transpose of the matrix, then both the det of A or A transpose will be same. This is what this property says. That means if the rows of a determinant is changed to transform to their corresponding columns, corresponding rows, first row change to first column, second row to second column, third row to third column. So whenever there is a change of corresponding rows to the corresponding columns, then the determinant will be same. That means here if it is det, then here also it will be det, determinants. Okay. Chalo, let's move on to the property number 2. Okay, let's move on to property number 2. What does property number 2 says? Property number 2 says that this is our det, default we have taken this det, and this is our another det. If the det will change from this to this, so what is the change? What is the change in these two? In these two, change is R2 had become R1. So you can say here we can say that, see that here R2 is A2 B2 C2, it had become A2 B2 C2 in this. So R2 has changed to R1. So there is a interchange between the rows. Such type of interchange can also be possible between columns. There can be C2 change to C1 or C1 change to C3. Anything can be possible. Okay. Now, once such an interchange of rows or columns takes place, then det will become negative after the interchange. Okay, after the interchange, the det will become negative. Okay, suppose I had done change R2 to R1. Then first suppose my det is 100, then my det will become minus 100. Okay, for the examples, please go through the notes. I had explained one example over there that will be suitable for you. Okay, now if I will suppose do the two changes like R2 to R1, after that again R3 to R1. If two changes are there, then again this det will become positive, because for first change it will be negative, for another change again it will become negative, and negative it will become positive. Okay, so this explains about property number 2. Let's move on to property number 3. Let's move on to property number 3. What does property number 3 says? A determinant which is in the form of this will be equal to 0. A determinant is either this or a determinant is 0. So what is the change? Change is two rows are identical. You can see it is A1 B1 C1. Here also it is A1 B1 C1. Both the rows are identical. Okay, what are the rows? R1 and R3. So here what is the change happened? Change happened is R1 is equal to R3. Not only rows, columns can also be identical. If any two columns are identical, then determinant will be 0. Okay, do you understood this? Whenever the columns or rows are identical, then determinant will be 0. Why? Because if you go to the detailed explanation of our matrices, I told you about the row operation and the column operation. Once we perform the row operation between R1 and R3, that is R1 minus R3. Okay, R3 tends to R1 minus R3, then A1 minus A1 will become 0, B1 minus B1 will become 0, C1 minus C1 will become 0. So that means my R3 will be 0, 0, 0, and once you expand through this row, R3 row, then this determinant will become 0. That's why the determinant is 0. Okay, for the example, please go through my notes. Chalo, move on to property number 4. Okay, let's move on to the property number 4. In this property, our determinant, we had taken a default determinant of A1 B1 C1, A2 B2 C2 and A3 B3 C3. If we multiply any number to the determinant, number is k, any scalar, any number k, then that k will be multiplied to either of any of the row or any of the column. Okay, k can be multiplied to the any of the row or any of the column. I had multiplied here to row 1. I had multiplied here it with row 1. Okay, so it can be multiplied with any of the rows or any of the rows or any of the columns. Okay, why we are doing these all properties is we have to use these multiplication and all while solving our problems. Okay, so suppose this is my det and I want to transform my elements in the multiples, then I can use this property and I can tell that I can write 1 by k here and I can multiply k with my row elements. Okay, so this is how we have to use these properties while solving the problems. This will be explained in our workshop sessions. Okay, please go through the notes for the example. Okay, this completes the property number 4. We will go through property number 5 now. Okay. My property 5 says default determinant of that if I will change my first column as a1 plus x, a2 plus y, a3 plus z, then my determinant I can write it as, or the determinant will become a1 b1 c1, a2 b2 c2, a3 b3 c3 plus x y z b1 b2 b3 c1 c2 c3. Okay, so what I had done here I had written a1 a2 a3 as one of the column. So same column we can write it here, and plus we can write x y z as one of the column. So if we will sum these two determinants, determinant 1 and determinant 2, then we will get this determinant of this. So proof of this, please go through the notes. Okay, so this type of properties are very important in solving the problems related to the determinants. Okay, this completes determinant property number 5. Okay, for property number 6 we will have it next. What does property 6 says? Property 6 says that my default determinant of a1 b1 c1 a2 b2 c2 a3 b3 c3 is equal to this determinant. Either I can write determinant like this or like this, but in this we can see our column number 1 is screwed up. Column number 1 is a1 plus mb1 plus nc1, a2 plus mb2 plus nc2, a3 plus mb3 plus nc3. Okay, how we are telling that these two are same? I told you that we had already done the operations of the row classes. So in those operations of the row classes, we will come up with one of the operations that c1 tends to c1 minus mc2 and c1 tends to c1 minus n c3. That means column number 1 minus m into column number 2. If I will do column number 1 minus m into column number 2, then I will be left with a1 plus nc1, a2 plus nc2, a3 plus nc3, because mb1, mb2 and mb3 will be deducted from this, because this is multiplied with m and we had reduced it, right? This is one of the column operation we had performed. Whatever we had done in this, after that we will perform this operation, then c1 minus nc3. So m1 all got cancelled out. Now we are left with nc1, nc2, nc3. Same nc1 will be subtracted, nc2 will be subtracted, nc3 will be subtracted. So we are left with a1, a2, a3 at the end. That means both the determinants are same. Okay, so this is the exhaustive property based on the rows operation. Okay, chalo, this ends the properties of the determinants class. What we had done in this class? In this class we had learnt about 6 properties of the determinants. These properties will be applicable to the problems related to the determinants. So to solve those problems in our workshop session, these detailed explanation class are very important. So please go through in series. Okay, thank you and stay connected.